Any organization and their success is based on the people. And it's also based on the culture that those people generate internal to that organization.
The unique thing about what we're doing here at Astra is that we're not only designing and building and providing a thruster, we're building a whole entire propulsion system for our customers. Our capabilities that we're developing here at the facility allow us to not only test the thrusters, but the entire propulsion system as an integrated system.
When Adam and I first met, we imagined the potential of space. We imagined the idea of dramatically increasing access of space. We might all go to space for other reasons, to settle other planets, to spread humanity into the solar system. But for Adam and I, and for the whole team here at Astra, the mission is here on Earth.
Option received. Option received. Eco.
That is fairing separation. Stage separation.
We have some.
The payloads have started to communicate with ground stations. Our customers are calling us and indicating that satellites are alive. They're talking, which means they've been successfully deployed.
Red lead is go. FTS. FTS is go. Dolphin. Dolphin go. Ether. Ether is go. Odin. Odin is go. Inco. Inco is go. Ace. Go. Launcher. Launcher is go. Orbit. Go. Booster. GNC. GNC is go. FAL. FAL is go. CDH. CDH is go. Tango. Tango is go. Safety. Safety is go. Load is go.
The opportunity to improve life on Earth through these dimensions of a healthier planet and a more connected planet is truly something that has inspired all of the things that you'll see today.
6, 5, 4, 3.
So it's really a significant shift, almost like an Astra 2.0 in terms of how we do design, how we do verification, and then eventually how we conduct our missions and launches with a vehicle that is generated out of that new process.
To think that I get to touch in any small way a mission like this it's ineffable. It is beyond articulation. Getting to work on anything related to improving life on Earth from space, I kind of have to pinch myself when I think about that. And what a dream to work on this with all these amazing people, truly.
Hello, everybody, and welcome. My name is Margot Denary. I'm the Vice President and General Manager of our Astra Spacecraft Engine business. It is my great pleasure to welcome you to Astra's second annual Spacetech Day. But before we get started, our lawyers tell me that I need to cover this very important slide. So I'll give you a moment to read it. It's our legal disclaimer and forward-looking statements. Good. Okay, great. Now that we've got that over with, it's my privilege and honor to introduce to you our founder, chairman, and CEO of Astra, Chris Kemp.
Thanks very much. Cool.
thank you guys so much for coming. It's an incredible day when we get to have the opportunity to pull everything together for you all. Spacetech Day 2023 is the second annual opportunity to bring our customers, our shareholders, analysts, so many of our employees together to see what this team has been doing for the past year. So as we think about what happened over the last year in this industry, we've seen new companies emerge. We've seen a number of companies go public. We've seen the war in Ukraine highlight the criticality of seeing what's happening in space. And our team has been so inspired by all of these things that have been happening around the world, and it's what drives us. If you look at all of the things that have happened, it's been a year of building. When Adam and I first met, we knew that the only path to a vibrant and successful space economy was through space access. And we started with a thesis that more infrastructure would be built in space. And in order to bring that infrastructure to space, we would need to make investments in a scaled capability. We would need to make more rockets or a bigger rocket. We had to choose a path, right? And being somewhere in the middle, as we shared last year, was not where you want to be. You either need to build the world's largest rocket and use it an infinite number of times, or you have to build a very large number of rockets and drive through economies of scale all of the costs out of manufacturing, out of the operation of the vehicle, so that you can reach an inflection point where you have a product that can be sustained in the marketplace. So throughout the year, despite headwinds, we made these investments. These investments started the day we took the company public. We remained committed to making the investments in the hardware and the infrastructure that would drive costs down for our customers and create a lasting place for Astra in this market. And I'm so excited to have you all here today because this is not something I can do on Zoom. It's not something we can talk about in press releases. It's something you frankly have to come and see for yourselves. So for those of you online, for those of you here in the audience, you'll have the opportunity to walk the production line, to see some of the things we've built. When we bring our customers here, they see what we're doing. The Space Force has been working with us for the past 18 months on an opportunity to fly new national security payload missions on Rocket 4. They saw the commitment from our team. This is a high level of mission assurance that we wouldn't have been considered for a year or two ago. Our commitment to reliability, our commitment to learning from the launches that have been successful, unsuccessful, is what allowed the Space Force to give us this opportunity to launch one of the first flights of Rocket 4, a national security high mission assurance payload. So we're incredibly grateful for the confidence that the Space Force has in our team here at Astra to deliver this important mission. NASA continued, even after we were unable to deliver their satellites last year, to renew that contract to give us opportunities to launch future NASA missions under that same contract. So the confidence that our customers have in this team is incredible. As we've seen over the last year, more and more satellites are being launched. We're seeing the Amazon satellites come together. They should be launched here in the next few months. SpaceX has launched the largest number of flights, I think, have been launched in the last year, if you look at the total global rocket launches. And it's because we're seeing a growing demand for satellites in low Earth orbit. The forecast now is over 40,000 satellites will be placed in low Earth orbit this decade. That'll generate an opportunity for over $100 billion in launch market revenue. And the global space economy grew at its fastest rate in the last 7 years at a 9% CAGR last year. And this was in the backdrop of an economy which is struggling in other areas. So we're seeing a lot of signs that when Adam and I first met and we believed that the space economy would grow, we believed that small satellites would have a critical role in national security, in our communications infrastructure, and our ability to manage our planet. This is evidence that there is scale in this industry, and the investments that we're making are in the right areas. So we've seen Apple roll out a new feature on the iPhone that's saving lives because a phone can now talk to a satellite. We're seeing other carriers partner with other constellations to provide more bandwidth and more data. We're seeing more countries provide more broadband access. We're seeing incredible capabilities emerge with synthetic aperture radars, with new imaging and hyperspectral imaging capabilities that simply just didn't exist 5 years ago. So this is a completely new platform that's being built. Just like mobile phones and cell phone towers enabled a whole new wave of commerce, space and space infrastructure is enabling a whole new set of platforms. So it was a difficult year for Astra, and there's no way to sugarcoat that. We were manufacturing 1 rocket per month in this factory before we built this out. And we had 2 launches within 33 days of each other. We demonstrated the ability to go to Cape Canaveral, conduct the first Part 450 license in under a week with a team of 6 people. These are incredible accomplishments, but we were unable to deliver a critical payload for NASA, and that set us back. And so we made the very difficult decision as a team that we needed to focus. And what that meant was all of our aspirations that would require more capital to go and work on satellites and to go further expand some of our other businesses would need to wait. And so we focused all of our resources on these 2 areas of our business, delivering a reliable launch system, launch service, and on what turned out to be an incredible surprise for us. We started selling spacecraft engines, and then we sold more spacecraft engines. And we're going to hear from Margot about this incredible success that we've had. And she's going to tell you a lot more about what they're doing with these spacecraft engines and why they're so critical. But this has turned out to be a very important revenue stream for the company. As we start to ship these spacecraft engines, it allows Astra to have 2 different pillars of growth. And the spacecraft engines give us visibility into the satellites that are coming out. And so these 2 businesses are very complementary, and we're really excited about the opportunity to serve customers both in space and also on the way to space. The other theme that we're going to bring to you today is reliability and scale. When we started working on the very first Rocket 1.0, Rocket 2.0, Rocket 3.0, now Rocket 4.0, it wasn't clear to us the investment that needed to be made to achieve these 2 things, and they are so intertwined. You cannot have reliability without scale, and you cannot have scale without reliability. If you have a flight that doesn't work, you're grounded for months or potentially longer. So you need reliability to achieve scale. And the engineering team that designs a system of this complexity has to design it so that other people can test it, other people can build it, and other people can operate it. So this product lifecycle is actually not an 18 to 24-month, 36-month lifecycle. It's probably a 3 to 5-year lifecycle for a particular version of a system of this complexity. And so it was clear to us that we had to immediately focus all of our energy on the new launch system and not continue to have resources devoted to operating and upgrading a system that had the capacity that might have been relevant 5 years ago, but isn't relevant today or 5 years from now. And so we made the decision to pull forward what we were calling Rocket 5 into Rocket 4 to upgrade our upper stage to have a turbopump-fed engine and to partner with an incredible company that actually started before Astra called Ursa Major. And just yesterday we announced this partnership. The entire team at Ursa Major has devoted all of their capital, all their resources on one thing, which is the Hadley upper stage engine, or the Hadley engine that we're using in our upper stage. And so we're really excited to announce that partnership because it allowed our team to focus all of its energy on the first stage engine and on the rest of this very complex system. So I wanted to highlight how important not just the rocket is. We all like to talk about rockets, but rockets are really just a small piece of the puzzle to achieving reliability and scale. Today, you will see what we're calling the rocket production line. It'll be a tour stop. I don't believe a machine like this has ever been created. This is a capability that we've been working on for several years. The final big machine dropped on the production line just a few weeks ago. It takes a coil of aluminum in one side of the building, and it processes it through various stages, and rocket stages come out the other side of this machine. I don't think another one of these exists in the world. And this will allow us to drive the cost of the primary structure of the vehicle down like a gigafactory and presses drive the cost of vehicles down. We're literally pressing primary structures out of sheets of metal and taking rolls of metal and turning them into the tanks of the vehicle. And you're going to see this on the tour here in a few minutes. I could not be more proud of the engineers that worked on designing these machines, the teams and the partners globally that we've had building these machines, and now putting these machines in operation. So Rocket 4 will be made on this new rocket production line, and this rocket production line can produce, it's been designed to produce up to a rocket a day, which is an incredible amount of capacity. But when you think about a 1-ton class vehicle, you know, a single Starship is 100 tons. And so, if you're in the 500, that's somewhere between, 100 and 200, 500 kilogram to 1 ton class vehicles. So it's actually not that much. So if you believe in a market of 1 or 2 starships worth of things going to LEO, you can certainly believe in daily space delivery of a vehicle of this size. But there's more. We've doubled the capacity of our shop. This is an aerospace-grade machine shop that can manufacture many of the components on our system, a quality control lab. Adam London, my co-founder, is going to talk a lot more about reliability in a few minutes and how we're thinking about that. We've built new test stands to test all of the different components. We're spending a lot more time before we get to the launch pad testing engines, testing valves, testing stages. And so this requires time and capital. And so we've been very thoughtful about how much we're investing in the various stages of the development process, so ultimately we do have the highest probability of a successful flight. But it's not just a rocket, it's a new launcher. The tour will include, you'll see the new structure of our new launcher outside here in a few minutes. And this infrastructure is what allows us to move complexity off of the vehicle onto the ground. And again, this is designed to support the fewest number of people in the field. And I would be remiss not to include software. A brand new mission control experience that's been designed to dramatically increase efficiency, productivity, and safety. A new data platform. Every sensor on every vehicle, on every test stand is sucked into a platform that gives all of our engineers the ability to do analysis and compare different components across time. It's an incredible platform that's all built here at Astra, and a new launch system simulator that will increase our ability to simulate not just the rocket and the flight of the rocket, but everything that happens in the ground system as well. So people like to talk about rockets, but what this is this is an entire platform that teams of people are working incredibly hard on that all comes together. And what's exciting about today is we've been able to pull a lot of the pieces together to show you them for the first time. So as you fly through our factory, you'll see just past the inventory cage at the beginning of this new production line, where coils of aluminum are flattened, laser cut, re-rolled, friction stir welded, circumferentially welded in one continuous production line. This is an incredible capability. And you'll get to talk to the engineers that designed this here in a few minutes, for those of you on the tour. And when you think about the factory, what the factory really does is it allows us to increase scale, but the automation in the factory allows us to have consistency as we build the components of the system, so we can actually increase quality as well and reliability. 100% of our critical components, which we've identified, run through a brand new quality control lab, so we can know what parts are going on this rocket. We can now do next-day part production. So this gives us the ability to be very agile. We can take raw materials and turn them into the components, so we're not sitting on expensive inventory, drives down costs. And then we have the ability to test nearly everything on site. So the vast majority of all the tests that are performed prior to a flight happen here on this campus. And so again, all of these things are very unique to Astra, and this vertically integrated strategy gives us the ability to do this without having people travel, having to rely on third-party suppliers. The launch system is mobile, and why this is becoming increasingly important is space is a strategic capability. You've seen the Space Force go from not existing to having a budget, which is tens of billions of dollars just in the last 2 or 3 years. And this investment is for a reason. It's because space is strategic. If you have things happening and you can't see them, if you can't connect to them, or if you're relying on infrastructure that can't be reconstituted, that's a problem. And the problem America has right now is this infrastructure is launched from 2 locations, Cape Canaveral and Vandenberg. And if anything happens to those locations, we can't reconstitute critical infrastructure. So we've designed this system so that we can place a launch system anywhere that we are licensed to operate. The lawyers wanted me to say that. And conduct a launch with just 5 or 6 people. And this capability means we can place rockets and this infrastructure, which is all manufactured here, on trains, on container ships, on trucks. We can place it, and then we can start reconstituting infrastructure. This drives resiliency. And resiliency of critical national infrastructure becomes a national security priority. So we're really excited to be partnering and demonstrating these capabilities, because as space becomes more strategic, so does this capability. And I believe that Astra is one of the only companies positioned to deliver with this level of agility and mobility today. It's designed for small team operation, and it's designed for a one-day turnaround capability from launch to launch. So we can launch a rocket, and then we can reset the entire infrastructure so we can be prepared to launch again. Software is one of the key enablers. So we're moving now to a two-person mission control experience. When I was at NASA, we like to look at mission control as this incredible, dozens of big screens and rocket scientists looking over all their systems. That drives cost. And it means that you need specialized talent at each of those consoles to be studying data to make decisions about whether the thing should work or not. We've moved all of that into software and automation. And so this has been a journey we've been on since Rocket 1.0, where mission control went from 18 to 12 to 9 to 6, and the design for Rocket 4 and the new Launch System 2 is a pilot and a co-pilot. Why should you be able to get on a trans-Pacific flight with hundreds of passengers with a pilot and a co-pilot when an autonomous rocket flying with no people on it in the middle of nowhere, delivering a payload to space, shouldn't be operated by a pilot and a co-pilot? It's a software problem. We've been focused on the 24-hour ConOps, both in mission control and in the field, and building simulation platforms so that we can actually do launches before there's ever a launch. And so what I'm really excited about is seeing our mission control be manned against just data that's simulating a launch. And we can start throwing scenarios at it. Months and months before launches actually occur, we're actually doing launches on actual hardware. This is very exciting. Finally, the team knows how critical it is that we return to the pad and test this system. So we are working tirelessly to drive towards test flights at the end of the year. Because the more we're able to get this system pulled together and tested, test again, the more we're going to be able to return to flight with a reliable commercial service. There's a really big change in Astra this year versus last year. I believe on this stage last year, we had a gentleman from NASA talk about how, the mission that NASA had designed around tropics only needed 6 out of the 9 satellites to be a successful mission. And while that was true, because our first flight didn't work, we lost the mission. And that wasn't acceptable. It wasn't acceptable to us. It hurt. It wasn't acceptable to our customer, and it wasn't acceptable to our shareholders. And so this time around, we're focused on success above schedule, right? And so we've really placed a tremendous emphasis on the rigorous engineering processes, the testing, the failure mode analysis. And with that, I'm going to introduce my co-founder, Dr. Adam London. We've moved the mission assurance organization, which has been heavily invested in, under Adam. So it's independent from engineering, independent from launch operations, and has the independent ability to say, no, we're not ready. And so we've made a number of changes across the company to prioritize success on our next flight. And I think that's a great segue to introduce Dr. Adam London, our co-founder and CTO.
Thanks, Chris. It's so exciting to have you all here at Astra today, and I'm excited to spend a little time telling you about how we're thinking about reliability. As Chris mentioned, as we were ramping up Launch System 2 development and spacecraft engine production, we decided to move our mission assurance organization to report directly to me, independent of engineering, production, and operations. And this team and I, together with all of Astra, are working tirelessly towards 2 goals: a successful first launch of Rocket 4 and the successful operation of every spacecraft engine on orbit. Today I'm going to talk mostly about the launch system, but our approach to reliability applies to our spacecraft engine as well. I gotta say, I'm really and continually impressed in the creativity the universe shows in different ways for rockets to fail. So the universe is throwing all kinds of potential failures at rockets. Design failures, process failures, random failures, often combinations of many of those. So our task to build a reliable launch system is to create 3 overlapping shields to catch all of these potential failures, ultimately enabling reliable and repeatable mission success for our customers. The first is a reliable design. Designing reliability in our system should be our first and our primary shield against failures. It's much easier and better to design reliability in the system than try to add it later. Next is a dependable manufacturing process that ensures quality and that the as-built rocket matches the design each and every time. Lastly, we have a robust test and launch operations shield to confirm that the launch system is ready to fly and to capture enough data during operations in flight to understand the system performance and anything that's off nominal in a flight to feed back into our system and our reliability. So let's talk a bit about each of these. Reliable design. Reliability, as I said, must be designed into the system from the beginning. It can't be an afterthought. And it's not just the design and the reliability of the rocket, but the design and the rest of the system has to be designed for reliability as well. The manufacturing system that produces it, the ground system that prepares it for launch, and all the software tools that we use both to fly the rocket and to automate our operations and our data analysis all come together as an integrated system design that enables a reliable operation. One of the most important things to build such a thing is experience. And the combined experience and the vast data from the dozen rockets that we've built and tested and the 9 that have flown is a tremendously strong base that I'm proud to build upon. So for Rocket 4, we've definitely turned up our development rigor. We formalized Astra's gated design review process for each system and subsystem as it goes from a conceptual design all the way through qualification that creates consistency across the organization, both for launch and for the spacecraft engine. We're doing detailed failure mode analyses of each subsystem to identify opportunities to mitigate many more failure modes in the design itself. And all of this has resulted in more robust design reviews, better systems engineering, and more robust requirement verifications, both through test and analysis. We've also staffed up our analysis capabilities, resulting in improved structural, thermal, and fluid analysis capability. We often pair this with additional testing to anchor and validate these analyses. So here's an example where the payload interface experiment didn't quite match the analysis. And those are the kinds of things that you want to catch as early as possible and understand in your design process. So in addition to a lot of component level analysis and design and development testing, we're also investing in a much more comprehensive launch system simulator. This will extend the hardware in the loop simulator that we had and was so critical for the Rocket 3 program to the ground system and to the launch control system, and let us conduct many, many more launches in the simulator, both for development and for practice, so that when we show up at the launch pad, we've already done a lot of launches and we feel our system is well validated. The final step in the overall design to qualification phase is qualification. And that's where we verify that our design meets all of its requirements. Here, we're further emphasizing the criticality of test like you fly. So now any exceptions from that test like you fly mantra must be justified and signed off by me personally, as well as several other Astra leaders. The qualification process will typically include environmental testing like thermal, vibration, or shock as shown here, as well as functional testing that demonstrates the system's functionality and that it can operate throughout the expected flight environment, including margins. So you'll see that kind of thing in engine qualification campaigns or components or things like that. But once we've qualified a reliable design, it's time to manufacture it. And so the next shield in our process is the production process itself, where reliability is embedded throughout. One example is our investment in the Quality Control Lab, which helps ensure that all the parts that either we produce in-house or source meet their design intent before they go into manufacturing. Another example is a new friction stir welder. You'll see that on the tour shortly. It validates the integrity of each weld as it occurs based on sensors that are embedded in the machine. So we incorporate diagnostics and validation directly into the process wherever possible. We're also doing detailed process failure analyses on our most risky, hard to inspect, or hard to validate manufacturing processes, and using that to improve or adjust the processes accordingly. Once we've produced a rocket to its design, we have robust tests and operations. The final shield, and it's a final opportunity to catch potential failure modes, are the tests following assembly leading up to launch, as well as in the data from a flight itself. Our aspiration, of course, is not to catch anything at this phase, but we must always be vigilant. So once a subsystem is fully assembled, it will go through acceptance testing to verify its functionality and workmanship. These tests start at the component level, like a valve or an avionics box, and they continue up to an engine or even a full stage or rocket. As an example, here's a Hadley engine under test at our partner's facility in Colorado. And I stuck a spacecraft engine acceptance test in here because I think they're so cool. At that point, we're ready to head to the launch site, and there's still a series of verifications that we do that will culminate in a short static fire, as we did in Rocket 3. We've also improved and invested in our post-launch data processing to further automate the analysis and review of flight data to make sure that we can feed any learnings back into improving our designs and operations and identify anything that might be the sign of an opportunity to further improve the system. So with all the energy, with all the investment and all the focus that we're putting on reliability, I'm pretty confident in the shields that we're building for our system. And I do believe that we're on track to deliver a reliable launch system for our customers. I can't wait to test it about what the universe has in store for us and see it fly. As I mentioned, we also apply similar rigor to ensuring the reliability of our spacecraft engines. And I'd love to invite Margot back to the stage to talk about this growing part of our business.
Thank you, Adam. Hello again. All right. That was the wrong way. Okay, we're going to go this way. So thanks, Adam. One of the things I find myself doing often in my role is actually explaining what the Astra Spacecraft Engine is and why it's such an important part of increasing access to space, as well as Astra's larger vision. The Astra Spacecraft Engine is one of the industry's leading flight-proven Hall effect propulsion systems for satellites. That's a lot of words to get through. And so if you're wondering what does that actually mean, what do they do? For those of you who may not be aware, propulsion systems are one of the most essential parts of keeping satellites in orbit for LEO and GEO. Our engines enable satellites to maintain their positions, to continuously maneuver to avoid collisions, and very importantly, to safely deorbit to make space sustainable. Each one of our systems is delivered fully integrated and tested to reduce satellite development complexity while improving on-orbit reliability. Additionally, our design is flexible and can be configured with multiple thrusters, multiple PPUs to meet a wide range of mission objectives. In addition, you can also operate it with both Krypton and Xenon propellants, allowing customers to optimize around performance and cost. As of March 31st, I'm very happy to say that we have 278 cumulative orders of the Astra Spacecraft Engine. We're very happy to be powering critical applications such as national security, Earth observation, and communications, some of which are already operating successfully on orbit. In fact, as of this month, we have 9 Astra Spacecraft Engines on orbit. And while we're very excited that customers are continuing to choose Astra Spacecraft Engine for their propulsion needs, to meet this growing demand, we're continuing to ramp our scale our production at our new factory in Sunnyvale that was just commissioned last month. Our 60,000 square foot facility is designed to produce upwards of 500 propulsion systems per year with additional room to expand. It also includes our unique 3-station chamber which cuts test cycle time, which is a traditional manufacturing constraint, and allows us to produce high-volume manufacturing at scale. This is a picture of our test room, and you can see our 3-station chamber there on the left. And here's some actual footage of thrusters firing in that chamber that was taken, I think, just a couple weeks ago. I personally think it's beautiful. I'm biased. And here's a photo of our team that is assembling, testing, and delivering the first flight module out of that facility. So we're very excited to welcome some of you down to Sunnyvale later this afternoon to show you exactly what we're working on in person. So finally, as mentioned, the Astra Spacecraft Engine provides complete propulsion modules to meet a wide variety of customer needs. We offer integrated configurations of key components, including the thruster, the PPU, the feed system, and the tank. And now we're excited to introduce something that we've been working on to address even more satellites than before, and that's the spacecraft propulsion kit. Thanks. The propulsion kit enables satellite manufacturers to take advantage of very short lead times to access key components of the propulsion system. We're adopting the way dev kits have transformed the software industry and applying it to hardware and providing the support and tools to accelerate spacecraft development at scale. If you're interested, we have an example of our propulsion kit here on the table, so I invite anyone to take a look after our session today. And in fact, we just sold 5 prop kits last night. So we're very excited. Thank you for allowing me to share a little bit of what we're working on. And now I would like to hand it back over to Chris for one more thing.
Thank you.
Yeah.
Cool, thanks, Margot. And kind of in the spirit of announcing new products, and we're excited to make it easier than ever to incorporate satellite propulsion systems into satellites, I wanted to, on behalf of everyone here at Astra, announce Rocket 4. So what you're seeing is a combination of qualification and development hardware. All of our teams from across the company came together and started putting all the pieces together. This is the first time that we've done a fit check build for Rocket 4. The first stage assembly is actually the qualification article, which is the primary tank structure that will go into testing over the next few weeks. The first stage engines will be used in Astra's engine qualification campaign for the engines. The upper stage engine is actually fully acceptance tested for flight. The upper stage tank was our first tank build for the upper stage. And there's actually some things that you can't see that are actually on the rocket, such as our new upgraded thrust structure. We've cut holes in so you can actually see the upper stage engine, and there's a payload interface. And there's so many teams that are working on things like software that you can't see when you just look at the rocket. So on the tour, we're going to show you the new launcher platform, which is massive, but mobile and still can be constructed and transported. And I'm just so proud of all of the work. I mean, imagine last summer going into production, starting to launch rockets, and everybody's excited, and then having kind of the wind knocked out of you. Our team, the resiliency of our team, the passion and the energy around our mission, they didn't stop. In fact, they started working harder and started making even they're more committed than ever to the reliability and the quality of our products than ever. And this isn't easy. As we've seen over the last few months, this is a capability that has gotten a lot of attention, and a lot of teams are trying to succeed in this area. And Astra is a team that has been iterating and learning and reached space and reached orbit and put satellites in orbit several times faster than anyone. If there is a team that is going to pull together a capability, it's this team. And this factory was built in an economic environment where we could raise the capital to make the investments made to produce that machine at scale. And I think over the next few years, that's going to be challenging. And so I think Astra is in such a unique position, given these two businesses that we've built around spacecraft engines, around launch services, where we've made the investments, both in ourselves, the learning, the humility that comes from failing, and the passion and the energy that we're investing in reliability across all of these products. And we've made the investments in this factory. And that's why I'm so excited to stop talking. This will be the first tour stop. And you'll get to go around from station to station and see all the different hardware we've built that builds the hardware that's going to ultimately drive scale, drive reliability, and allow us to one day achieve our vision and our dream when Adam and I first partnered, set out to, which was daily space delivery. And we're so excited that we bet on this market, and we bet on the abilities and the capabilities and on all the things that all of these incredible companies and the US government and other governments are putting up in space. Because we don't do this to do this. We do this because of the impact that infrastructure in space will have on on humanity. It is the next platform. We've always believed that, and it's what inspires us every day to improve life on Earth from space. So with that, I'm going to hand it back over to Doug to go over ground rules for the tours. Standing room here, thank you all so much for coming today. We hope you all enjoy the tours, and we'll see you here next year. And hopefully we'll be talking about a successful test flight of Rocket 4 at Spacetech 2024. Thank you all.